The focus of what we're going to do here is to replace the main capacitor in the unit here. I've tested the unit and it runs with an intermittent spark. I hope that the new capacitor will make that go away. And then the other thing is the capacitor is underrated. It's rated at 250 volts, and many of us have measured voltages that exceed that routinely. So I think it's a good thing to do is to increase the reliability of the unit to replace it with a modern 400 volt capacitor. First thing we had to do is prepare the back side of the printed circuit board. To do that, initially Barry did most of the work for it, and initially, just for the video, I started removing some of the rest of the epoxy we needed down here, and made a mistake of getting down here close to these trigger coils. So this is exactly what you don't want to do, is these little trigger coils are here and here. Don't get anywhere near them, because we don't really need to expose all of that, and if you get too close to the trigger coil, you could destroy the whole unit. So I did make a cut here with a hacksaw, and we can go like this, and bingo, the last little piece came off, so I don't think we need that to do any more. The main capacitor goes between here, one end of the capacitor, and the other one is over in here. So what we're going to do is disconnect one end of the capacitor and just abandon it in place, so it'll be out of the circuit. And we can disconnect it by just cutting the pads on the printed circuit board here to disconnect this wire from this part here. So I'm going to go ahead and do that. Okay, I used a little cutoff wheel on a Dremel here and cleaned off the copper traces on a printed circuit board around the capacitor connection, which is right here. You can't see it in on, but I saved a little stub of that because later on I think I want to test the old capacitor while it's isolated from the rest of the circuit. But we're going to come back to that. So with this, then we're ready to think about installing the capacitor. Okay, the capacitor we're using is one that is specifically designed for charging and discharging repeatedly, and that involves a lot of currents in the capacitors, and they're not all made the same. So I would strongly encourage you to use this type of capacitor at least if you're going to do the replacement. The other thing about this capacitor is it has a very low profile to it, so we can mount that directly on the printed circuit board and not have to be concerned about hitting the flywheel. There's plenty of clearance in there, and if you wanted to check it, you could take some of your grandkids' Play-Doh and put a dab on there and check it. But the capacitor is I obtained it from Mauser. It's made by Cornell Doubler. Cornell Doubler part number. It's a thin film capacitor, much better than the technology that was in the old capacitors. It's rated at 400 volts, and it cost a little over $2. And you can get the data sheet on this Mauser part website there. So this is the capacitor that we need to mount on the board. Okay, one thing I should notice, if you take your unit and put your thumb on it, you can feel sharp points sticking up from these parts. And we're going to mount a capacitor right there, and we don't want any of those sharp points poking holes in our capacitor. So while I had that Dremel tool with a disc on it, I went over and knocked down any of the high spots on these parts that could damage the capacitor. So at this point, we're just going to mount this thing in here. We've got all of this stuff here for a connection, and the other end has to go right in here somewhere. So I'm going to bend the wire leads to accomplish that. Okay, this is the pad here that we need to make one connection to the capacitor. Now these printed circuits boards do vary, and so you're not obviously going to see this one configuration all the time. So if you're trying to do this and you don't know exactly where to put the wire, my suggestion would be take a good sharp photograph of it with somebody into photography, send it to me. I can mark it up with Photoshop and send it back. But I tinned the wire here, cleaned it and tinned it, so we can prepare to solder the one lead for the capacitor. Okay, at this point I have soldered one lead of the new capacitor right here, and then after doing that, this one was easy, soldered the second lead over here. So that gives the ignition a new capacitor. Normally the next thing to do would be to seal it all up, and I use E6000 industrial adhesive. For that I can either get hardware stores or Lowe's or hobby stores. So before I do that though, I'm going to run this ignition again on the engine simulator and see how well it works. Okay, I ran the unit on the engine simulator and I got a very loud, snappy blue spark. So the ignition is just working just fine. There was no intermittency to it at all. I should point out to you that this is a capacitance discharge ignition system. What we have here is a charge coil. When the magnets fly by that, it goes off and goes through a diode. It charges this capacitor up. It's a 1 microfarad, which is a pretty sizable capacitor, and it charges it up somewhere up near 400 volts. So there's a lot of energy stored in that capacitor. Now when the flywheel goes by the trigger, at some RPM here, the advanced trigger, it will trigger an electronic switch which will basically short all that energy in a capacitor right across the primary winding on the transformer. The output is many times more, and so you might get 26,000 volts out of there. One thing to remember, the capacitance discharge ignition system is, the spark is very different from a magneto spark or from an automotive type make-break spark. This spark is blue. I could hear the spark before I could see it, because I suspect that some of the energy is in the ultraviolet spectrum where I couldn't see it, but some of it was blue. In a magneto type ignition, you're used to seeing a white spark, and a spark that might oscillate and hang around for a while. This one is not that way. When this capacitor gets shorted against the primary winding on the transformer, it discharges within a millionth of a second. Bam! And that's the end of the spark. So it's all finished at that point. So anyway, the CDI spark is quite a bit different than the white spark. After I tested successfully, I potted underneath the capacitor initially first with some E6000, and then this had a chance to set up, so I sealed this all up again, and so protected from the weather. So at this point it's ready to be installed and go. Oh, one thing I should point out, this connector here is called a flag connector. It's a special connector in here, and it's all tucked in here so it doesn't touch the flywheel. The wire from this thing has to go down here like I've shown it, and it goes out behind the flywheel where so the flywheel cannot rub on it. So the way you wire this thing is there's only one right way to do it. or you're going to have maybe a spark for a little while till the wire rubs through, and then you're going to have a failed ignition again. So notice how the routing of this wire is. So that's the end of this clip. Thank you.